All right, so we're looking at this question from the exam, 2012 exam, and that's calculating the area between this curve. Now, as I've said, if you're not given the curve, you need to picture what it looks like. Or in this case, we're told that we're trying to find the area between x equals 1 and x equals 2. Let me just first of all get a pen up rather than an eraser. It's not going to help. But if I throw in x equals 1 into this equation over here, and I throw in x equals 2, if I throw in x equals 1, I'm going to get a y-coordinate of 0. Same thing for 2. And if I throw in a number like 1.5, I'm going to get a positive value. As it turns out, I know that the curve is going to be positive. I don't know what it looks like, but it's going to be positive, which means that we have positive area, so I can just write that the area is equal to 1 to 2 of x minus 1, 2 minus x. Now let's see how long we've taken to do this so far. Well, a minute. Okay, we've got 4.5 minutes to do this question. I've left out a dx. Well, to do this, we need to do a u substitution. So I'm going to let u equal 2 minus x. So du dx is equal to minus 1. But this is a linear substitution, this one. How do I get, if I let u equal 2 minus x, how would I get x minus 1? What does that equal? Well, let's rearrange. This always happens to me. I lose my pen. I don't know what the hell is this. Computer is retarded. Let's try. Lost my pen again. Let's see if we can do the question in the time allotted by losing my pen. How do you get the pen back? My God. Freaking stupid computer. And this is all on YouTube to see too now. Boland, what can I do? God. Oh, it's back. It's back. It's schizophrenic, this thing. All right. Well, if I've got u equals 2 minus x, x is equal to 2 minus u, so x minus 1 would be 1 minus u, wouldn't it? Okay, that's a linear substitution. So I'm going to replace, but when x equals, I'm doing a u substitution, so when x equals 1, u would be equal to 2 minus 1, which is also 1. When x equals 2, u would be equal to 2 minus 2, which is 0. Okay, so now that area is equal to, not going to change anything yet, but I am going to say that x minus 1 is 1 minus u, and that is the square root of u, du dx dx. However, du dx was negative 1, wasn't it? And I don't see a negative there, so I could throw out a negative out the front, and we'll leave it as 1 to 2 for now. Going down here, that area is therefore equal to, now I change the signs, I'm going to change the terminals, that is when x equals 1, so that's from 1 to 0. Negative. If you like, I could have switched those terminals around again and got rid of that negative. I might just leave it for the time being. What I'm left with is 1 minus u, u to the power of a half will do, du. Let's do that. That's the same as, well, u to the power of a half. The antiderivative of that is u to the power of 3 on 2 over 3 on 2, which is 2/3 u to the power of 3 on 2. And then the next one is minus u to the power of 3 on 2. Applying that So that's going to be minus u to the power of 5 on 2 times what? 2/5. If you need to break that up into more steps, go for it. I'm just doing that like so because it's right. Oh, I hope it's right anyway. Okay, so if we're going over here, now we can evaluate that. I'm throwing in 0. If I throw in 0, that's naturally going to be equal to... all of that's going to be equal to 0, isn't it? Subtract, but I'm subtracting a negative. So in other words, I'm adding... let's throw in 1 in there. That's going to be 2/3. 2/3 minus 2/5. And 2/3 minus 2/5 is, what have we got? We've got to get 5. 10 on 15 minus 6 on 15. Is the answer 4 on 15? Look at that. 4 on 15. Units squared, if you like. Now we've again. All right, so yes, we are right. And of course, if you were doing that without explaining, I think you could do it with probably about 2.5 minutes if you really were pretty sound and flash, which means you would have bought yourself a couple of minutes. I think that this question would have polarised as either the students that can do it or the students that can't. Have a look at that. 30% of students got 0. 49%, or let's just say half the cohort only got 0 or 1 mark. Of which, so it goes to show that if you don't practice this sort of stuff and if you don't keep up with it, you will make a mistake along the way. It's really important that you practice as many of these questions as you can. As we have also talked about, signed area, a lot of students might have had negative 4 on 15, and that's not valid. Area is positive. And yeah, a lot of errors occurred. If you have an error nice and early, then you can more or less guarantee yourself 0 marks. If you omit the dx, almost guarantee that you'll lose at least 1 mark, despite the fact that it is all correct. Linear substitutions. A lot of students might not have realised that or changed the terminals. That would probably be a common mistake. Let's have a look at this one now, and this time it's another 3 marker, but what must we do before we actually go ahead and do this one? Well, can't we do polynomial division? Let's do. Didn't I say that if the polynomials had the same degree or the one on the top was higher? Do polynomial division. So let's do that first. 2x squared plus 3. I've got x squared plus 1. How many times does x squared plus 1 go into 2x? What's the first thing? 2. And then I'm multiplying back through. 2x squared plus 2. Then I'm what? I'm subtracting. So I've got what? 1 remainder? Okay, so how would I then write that? So therefore we could say that 2x squared plus 3 on x squared plus 1 is equal to what? 2 plus 1 over x squared plus 1. Brilliant. Okay, now getting that I would imagine would be a mark. Shh. Now we want to find the area enclosed by the graph x equals minus 1 and positive 1. I don't know, do you think this is going to be symmetrical? Yeah, it's going to be would you agree it's going to be symmetrical? Or would you agree that it's going to be positive? It's all going to be positive. So if it's all going to be positive, let's not worry about whether it's symmetrical or not. But we're looking at positive area, aren't we? Once again, lost that pen. I don't know where it's gone. Really gives me the irrits. How it just disappears like that. God, this gives me... Start this again. Therefore, the area is equal to, and we know that it's positive area because we've had a look at it, and we know that x squared plus 1 has to be positive, doesn't it? So it's going to be positive area. Don't really need to know what it looks like. But, excuse me, I've still got a few conversation in Mandarin whilst I'm trying to make a video. Zip it. Between -1 and 1. We don't know if it's symmetrical, so we won't bother dealing with or trying to make any shortcuts for ourselves. So that is equal to 2x plus, what have I got for 1 over x squared plus 1? Arctan, or inverse tan of x from -1 to 1. And that is equal to, I'm going to just finish that off, 2 plus inverse tan of 1, pi on 4. 2 plus pi on 4. And then I'm subtracting away, 2 times -1 is -2. So be careful of signs there, which a lot of students... What's the inverse tan of -1? Negative pi on 4. So that's so that is minus negative pi on 4. Try to write it out like that because you'll get thrown off by your negatives. Now that is, I've got 2 plus 2 is 4. Pi on 4 plus pi on 4. Pi on 2. That's your answer, yeah? Units squared. Now that's from the 2011 exam. Let's have a look and see how... Alright, so that was question 3 of 2011, of which the first part was just you actually had to show a given result, so that way you could use that later. Then you had to sketch a graph, so obviously we knew what it would look like. And 4 plus pi on 2, done fairly well, wasn't it? But it really was quite simple calculations, wasn't it, compared to the linear substitution we're looking at before. So I would expect more students to get that right. Okay, now the last thing I'll do for area is we're going to go through this question. Now I'm going to pause this graph here, pause this question here. It's from 2010. It's worth, let's just say it's worth 3 marks again. Now I'm going to give you 4.5 minutes. Then we're going to go over and I'm going to do it and see how long I would expect a really strong student to take. Probably you should be able to buy yourself a minute or so in a question like this come November. So I'll pause it now. Have a go at this question, please. I'll resume that one. All right. First of all, we're dealing with negative area. I'm going to try and do this as quickly as I can. The area that we're dealing with is between -1 and 1 of x squared, minus 1. This pen really sucks. X plus 1. I don't know why it's dragging along like that. However, it is negative area. So I'm going to throw a negative out the front, but instead of doing that, can't I just say that x squared minus 1 is 1 minus x squared? I could do that. That's fine. I could do that quite comfortably. Now, once I've done that, what am I doing to solve this? Substitution. Am I doing a u substitution or what? What am I letting u equal? Okay. So I'm letting u equal x plus 1 and du dx is equal to 1. But what about this? So what about then, what's x squared then? X squared would be equal to, would you agree that that's u minus 1 all squared? Is that what you guys did? Yeah. Yeah? Okay. And when x equals -1, u would be equal to 0. And when x equals, excuse the pen by the way, it's doing some crazy things again. X equals 1, u would be equal to 2. U would be equal to 2. So now my area is equal to Don't go changing the signs yet. Minus 1 to 1. 1 minus x squared is, well, 1 minus u minus 1 all squared. And x is u is x plus 1, so that is u to the power of a half. Are we okay with that so far? Now, du dx is 1. Oh, that's nice. We don't have to do anything with that. Du dx dx. Now change the terminals over. So we've got from 0 to 2. 0 to 2 of... And let's go apply this now. 1 times u to the power of a half is u to the power of a half. But I've got a negative. Shh, Jesus. You try doing math when you've got 4 conversations going in an exam, for example. There's a reason why it's exam conditions, you're perfectly quiet. Minus u minus 2u plus 1. And then that's times u to the half. Du. Okay, let's see if I can avoid making a mistake despite conversations going on whilst I'm trying to do math. All right, u squared times u to the power of a half. I'm adding those together. That's u to the power of 5 over 2. And that's u to the power of a half minus u to the power of 5 on 2. Minus 2u, no, positive 2u to the power of 3 on 2. Minus u to the power of a half. Okay, well that's nice. That's going to cancel out that, isn't it? Du. So what we've left with is hopefully this 0 to 2 of 2u to the power of 3 on 2 minus u to the power of 5 on 2. Does that look familiar to you guys? Good. Now let's go ahead and do it. I'm adding 1 to the power, which is 5 on 2.
Wait a second, I have u to the 5 on 2 minus...
All right, so I'm going to resume that one. So, now what we're looking at is throwing in 2 there. Now, 2 to the power, let's think about this. 2 to the power of 5 is 32. Square root of 32, that being to the power of a half. So, that is 4/5 of root 32. Would you agree? Minus, well, 2 to the power of 7. 2 to the power of 7 is 64. 2 to the power of, sorry, 2 to the power of 6 is 64. 2 to the power of 7 is 128. You've got to do this in your head too.
Yeah.
So that is minus 2/7. And that is the square root of 128. Yes? And then, of course, I'm subtracting 0. So that's what we've got. Now, we're looking for a perfect square. That's the same as 4/5 square root of 16 times 2. This is your year 10 maths here. Minus 2/7. 64 times 2. So I've got a 4, which that's going to be 16 on 5 root 2. And that's going to be an 8 out the front. Minus 16 on 7 root 2. I've got a common denominator of 7 and 5. Let's just multiply those two. Or multiply those two to find the lowest common multiple, which is 35. So I've got to multiply the one on the left by 7. 7 times 6. Dean is 112. Is that right? 112 root 2 on 35. Minus 16 times 5 is 80, isn't it? 80 root 2 on 35, which is equal to 32 root 2 on 35. And we know that that's right because look at that. Now, that was a pretty tough question in that there was a lot of areas to make mistakes, wasn't there? Calculation errors, incorrect use of substitution. That's as tough as it really gets, I would have to say. That was a tough question. So if you got that, congratulations. Hands up in here who did get that first time round. No? One. There'll probably only be a couple, especially at this stage of the game, when I'm sort of rushing you guys. All right. Now I'm going to. You can see there though that look, 45% of students got 0 or 1 mark. There's instantly. There goes your A+ most of the time. If you made a mistake there, but that was worth 4 marks. I want you to be up here. The 23% mark. There's supposed to be a little hand that you can't see. I might zoom right in. I want to see you here, guys. Yeah? I want to see you in the top 23% of the state. All right, I'm going to stop there, and this is our video on